Our next topic is the complex conjugate theorem. It says, according to the linear factorization theorem, a polynomial function will have the same number of factors as its degree. Okay, so that's what we just discussed in a previous video. And each factor will be in the form x minus c, where c is a complex number. If the polynomial function f has a real coefficient and a complex 0 in the form a plus bi, then the complex conjugate of the 0, a minus bi, is also a 0. And this is what we saw in the previous example in our video. We had a complex 0 of I square root of 3 over 3, and then its conjugate negative I square root of 3 over 3 is also a 0. So in other words, they come in pairs, conjugate pairs. So this one is actually 0 plus I, and this is 0 minus I square root of 3 over 3. So these are complex numbers with the real part, where the real part is 0. Usually complex numbers are written in this form. It's a, which is some real part, some number, plus or minus, and then we have b, another coefficient, multiplied by I. And that either a and b could be any real number. It could be a whole number. It could be an integer. It could be a irrational number like square root of 3. There is no restrictions on what a and b are, but the complex numbers come in this form. Well, as I mentioned before, real numbers could be written in this form too, with b is 0. When b is 0, then you just have your real number a. Okay, let's move on with this topic. And we're going to look at example 7. It says, find a fourth degree polynomial with real coefficients that has 0 of negative 3, 2, and I, and such that f at x equals negative 2 equals 100. Okay, so when x is negative 2, y is 100. So what we want to do, we want to find all zeros, right? And then once we have them, we're going to write our polynomial in this form. All right. So it says that the polynomial is the fourth degree polynomial. So we need either four different roots, or some roots are going to be repeated. But we need 4 all in all. Here we only have 3, but since we have an imaginary root right here, this means that we're going to have its conjugate as well, which is negative I is also a 0 of f of x. So now we have four zeros. So since we have each 0 gives us a factor, so we have some multiplier a, which we will find later. But let's write all the factors. So the first factor is x minus and negative 3. So that's x plus 3. The second factor is x minus 2. And then the next one is x minus I. And the last one is x minus a negative I, which will give us x plus I. Okay, so I have all of my 4 factors, and that will give me a polynomial of 4th degree. Now I want to find that a. So what's going to help me is the fact that they gave me 1 point from from that line, from that polynomial. So I know that these numbers should fit this description, okay? So this is what I'm going to do to find a. So I'm going to evaluate f at -2. And so it's going to be a, and then -2 plus 3, -2 minus 2, -2 minus I, and -2 plus I. Okay, so I know that f of -2 is 100, so I'm going to replace this with 100. And you know what else I'm going to do? So this is 1, this is -4. And here what I'm going to do, I'm going to multiply these. And so I'm going to apply that difference of squares formula, a plus b times a minus b equals a squared plus b minus b, sorry. So I'm going to apply this b squared. So I'm going to apply this formula here. And what I have is actually -2 squared minus I squared. Okay, so we have 100 equals a times -4. What do we have here? Well, we have 4 minus, and I squared is -1. So it's actually plus 1. So we have 100 equals, now this is going to be 5 times the -4, 20. So this is 20a. And from here, we're going to conclude that a is 5. A is 5. So now that I found that a, I can go back and plug it into that equation. Okay, so let's do that. And also, what I'm going to do, I'm going to multiply these factors. We could do it earlier. We could multiply them right here before we started putting in -2 for x. It doesn't really matter. We can do it right now. So f of x is 5. And when we multiply, first you can multiply in any order, you know, however you like, because it's just multiplication um, throughout. So I'm going to multiply x plus 3 and x minus 2, and that will give me x squared minus, okay, the inside will give me 3x, the outside plus, the outside is -2x, and the last is -6. Now multiplying x minus I and x plus I, we already did that. That gives us, oh no, we didn't. Okay, so again, applying this formula gives us x squared minus I squared. So we have f of x equals 5, and then I'm going to simplify this. X squared plus x minus 6 and x. Remember, I squared is -1 and a negative, so it becomes +1. So, and now I have to multiply these two, and I'm going to use a different method. This time, I'm going to create a table. So I have x squared, x, and -6, and I'm multiplying it by these terms, by x squared and 1. So what do we get? We get x squared times x squared is x to the 4th, x times x squared is x cubed, negative 6 times x squared, negative 6x squared. And then x squared times 1 is x squared. X times 1 is x, and negative 6 times 1 is negative 6. So these are our factors. This is what we were multiplying, and this is the result. And I'm gonna combine like terms. So it looks like I have x squared here and x squared, and that's it. Usually there is more. So the result of this multiplication is x to the fourth plus x cubed minus 5x squared minus 6. And now, so that's that times this. Now I need to multiply everything by 5. So my result will be 5x to the fourth plus 5x cubed minus 25x squared and minus 30. And that's it. Hang on. It looks like I forgot one term. I forgot about this x. So there will be an x, so there will be plus 5x also. But I mean, usually you would put it in, in front of 30 normally. Okay, so I'm glad we did not forget about it completely. But this is basically our polynomial that we build from knowing what the zeros are, knowing all of the zeros of the polynomial. And I want you to try this one by yourself. It says find a third degree polynomial with real coefficients that has a zero of 5 and negative 2i, such that f of 1 equals 10. Okay, so again, notice that you need a third degree polynomial and you have only 2 zeros. So you need to find a third one. And I want to make a note about polynomial with real coefficients. So it says find the first degree polynomial with real coefficients. So even though we had some complex and imaginary roots, right? When we multiplied the polynomial through, all of the coefficients that we have in that polynomial are now real. There are no imaginary numbers in the final result. So that's what they mean here, real coefficients.